Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR June 2023, Paper 2, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1a, write down the percentage of this circle that is shaded. Well, you can see it's one part out of 4, so it's 1/4. What's 1/4 as a percentage? Well, as a decimal, you should remember it's like 0.25, which is 25%, isn't it? So that's my percentage, 25. Shade 2/3 of this rectangle. So how many parts have I got? I've got 1, 2, 3, 4, 5, 6. So what's 2/3 of 6? Well, 3 goes into 6 twice. 2 times 2, that's 4. So I need to shade 4 parts of this. Okay, so 1, 2, 3, 4. There we go. Question 2, work out 20 minus 16 divided by 2. Now before you dive in, just remember the order of operations, which is the order that we do these things in, and we use BIDMAS, don't we, to try and remember which way round it goes. Now I've got a division there, look. So I've got a division and I've got a subtraction, which is here. So what comes first? So in BIDMAS you can see the D comes first in this. I'm going to do that first. So 16 divided by 2, that's 8. And then second comes the subtraction, and 20 take away 8. That's going to be 12 then, isn't it? So that's my answer, 12. Part B says insert one pair of brackets to make this calculation correct. I've got 2 plus 7 minus 3 times 8, and that's equal to 34. Okay, so how are we going to do that then? I think the brackets need to go here, don't they? So I had to think about that a little bit. So 7 minus 3, that's 4. So if BIDMAS would say I'd have to do that first, so that would make 4 times 8 plus 2, and then the next step I'd have to do the multiplication before the addition. So 4 times 8 is 32, and then adding on a 2 would give me 34. So that does work. So it's around the 7 and the 3. Question 3: a store carries out a satisfaction survey on a sample of its customers. The bar chart shows the results. So we can see very satisfied, satisfied, and dissatisfied. Against the number of customers. Work out how many customers were in the sample. Well, the number of the customers is going to be the sum of all the different bars added together, isn't it? So the very satisfied bar you can see is at a height of 24. So there are 24 people in here. The satisfied bar is at height 12. Look. So there are 12 in here. And then the dissatisfied graph, that's kind of halfway between 10 and 8, isn't it? So that's going to be 9. So there are going to be 9 people in there. Okay, so let's just get rid of those colored lines. So I got 24, 12, and 9. I'm going to have to add those together, and that's going to be the total in the sample, then, isn't it? So 24 plus 12 plus 9. What's that then? So 24 plus 12 is 36, plus 9 is 45, so that's equal to 45. Now notice I wrote the sum down first, in case you make a mistake with your arithmetic. You're still going to get the 1 mark available for knowing what to do, even if you didn't do it correctly. Okay, so then part B, the store manager decides to display the results in a pictogram. Complete the final row of the pictogram and the key. Okay, so remember the very satisfied column was 24, and we've used 1, 2, 3, 4 diamonds to represent 24. Okay, so 1 diamond then is going to have to be like 24 divided by 4. It's going to be 6, isn't it? It's going to be 6 customers. Okay, so then you can see the 2 diamonds is going to be 6 and 6 is 12, which matches with the graph. And then we need to show 9 people with diamonds. So 1 whole diamond is going to be 6. So then we need to show 3 more people, don't we? So 3 is half of 6. I'm going to use half a diamond like that to show my 6 people and my 3 people, making 9 people altogether. Question 4a, complete this statement by writing the missing value in the box. 17 over 5 is 3 and something fifths. Well, I know that 5 goes into 17 3 times. What's the remainder? 3 5s are 15, so that's going to give me a remainder of 2. So then that's the number that goes in there, is 3 and 2 fifths. Going back the other way, write 2 1/4 as an improper fraction. So the first thing we're going to have to do is multiply these 2 numbers together. So if I've got 2 whole ones and each one of those is divided into 4 pieces, then 2 times 4 is 8 pieces altogether. Plus you've got this extra one on the top here, haven't you? So 8 plus 1 is 9. So I'm going to get 9 quarters, then equivalent to 2 1/4 as a mixed number. Part C says work out 4/7 minus 5/14. So we've got fraction subtraction here. Addition subtraction, we need the same denominator before we can go ahead. At the moment we don't, because I've got a 7 and a 14. But if I take my first fraction, 4 over 7, and I times top and bottom by 2, then 4 times 2 is going to be 8, and 7 times 2 is going to be 14. And now I've got 2 fractions that have got a common denominator of 14. So these 2 numbers are the same. So that means I can go ahead and subtract. So I've got 8 subtract 5, and that's going to give me 3 then. So it's going to be 3/14. Does that cancel down? Nope. 3's prime doesn't divide. Then D, work out, given your answer as a fraction in its simplest form, 2 fifths times 15/16. Now you can go ahead and multiply numerator and numerator and denominator and denominator, but you're going to multiply bigger numbers and you're going to have to then look for common factors to cancel it down afterwards. Smarter, I think, to look to cancel first, and I can see 5 and 15 have got a common factor of 5. So if I divide that by 5 and that by 5, I'm going to get 3 at the top and 1 at the bottom. And then 2 and 16, they're both even numbers, so I can divide each one of those by 2. So that's 1 and that's 8. Okay? Now that's all the things I can cancel top and bottom. I've got 1 and 3 on the top and 1 and 8 on the bottom, nothing to cancel there. So now I'm going to actually go ahead and do the multiplying. So the 1 times the 3, that's going to give me 3. And I've got 1 times 8, and that gives me 8. Okay, now because I did the cancelling already first, I've got no cancelling left to do now. I know that's in its lowest terms already, so I don't have to bother to try and to simplify it any further. Question 5, we've got a couple of linear equations here. First, we've got x over 3 is equal to 6. We need to solve it. Now, to solve these, we need to get x by itself, and to do that, I'm going to have to times both sides by 3. And then that will cancel with that, leaving me with x on the left, and then 6 times 3 on the right gives me 18. So I've got x is equal to 18, so that one's solved. And then secondly, I've got 2x is equal to minus 14. So here I'm going to have to divide by 2 both sides to get rid of that number in front of the x. Leave me with x is equal to minus 14 divided by 2. That's minus 7, so x is minus 7. Question 6a, Alex is 1.34 meters tall. Gabby is 95 centimeters tall. Find in centimeters how much taller Alex is than Gabby. Okay, we've got mixed units here at the moment, haven't I? I've got meters and centimeters. So the first thing we're going to have to do is to convert them both into the same thing. And as the answer needs to be in centimeters, that seems to be the obvious thing to do, convert into centimeters. So Gabby's is already in centimeters. Alex, 1.34 meters. Now, there are 100 centimeters in 1 meter. So if I take 1.34 and I times it by 100, then 1.34 meters is the same thing as 134 centimeters then, isn't it? Okay, so then how much taller is Alex than Gabby? She's going to be taller by the difference then between their two heights. So 134 minus 95 then, isn't it? So what's 134 minus 95? So if I take off 34, it take me down to 100. Another 5 will take me to 95. 34 and 5 is 39. So that's the difference, isn't it? It's 39. Arrange these units of capacity in order of size, starting with the smallest. Now again, I've got all sorts of mixed units going on here. 3 of them are in litres. So I'm going to convert the one that isn't into litres first. 250 millilitres, what's that? Well, there are 1,000 millilitres in a litre, isn't there? Okay, so 250 millilitres is 250 thousandths, or 25 over 100, or 0.25. It's 0.25 of a litre, isn't it? 0.25 of a litre. A fifth of a litre, that's the same thing. If I times top and bottom by 2, look, I'm going to get 2/10, which is 0.2 litres. And the others are in decimal already, so I'm kind of good to compare these now. So which is the smallest one? It's going to be the one with the... It's going to be 0.199 litres, isn't it? That's the smallest one. Okay, because it starts with a 0.1, the others start with a 0.2 or a 0.3. Next biggest is going to be a flip up between the 0.25 and 0.2. If I add an extra 0 on here, look, 0.20, you can see that 20 is less than 25. So, you know, it's going to be 0.2 litres first. I'm going to write down what I originally had, though. That's a fifth of a litre. Okay, next biggest is going to be the 0.25 litres, or 250 millilitres. And then finally, the biggest one then is going to be the 0.3 litres. Okay. Question 7. ASME invests £700 at a rate of 2% per year simple interest. Work out the interest ASME receives after 1 year. Okay. So now we're going to start with 100%. That's everything. That's the £700. So what's 2%? Well, 10% would be a tenth of that. It would be 70. 1% would be a tenth of that. It would be 7. So then 2% would be 2 lots of 7. It'd be 14, won't it then? So note, we're just trying to work out what the interest is. We're not working out the final amount of the investment. So that's just the answer there, isn't it? It's going to be 14 pounds. And then it says work out the value of ASME's investment after 3 years. Well, after 3 years, I'm going to have the original principal value of £700 in the account, plus 2%, 2%, and 2%, which is going to be added each year. So it's going to be 14, 14, and 14. So adding those up, 4, 8, 12, carry 1, 1, 2, 3, and a 1 make 4. So that's £742 then after 3 years, simple interest. Wouldn't quite be the same if it was compound interest, obviously, because you get interest on your interest, but here you just add 3 lots of the interest on if it's simple interest. Easy squeezing. Question 8, increase 200 by 15%. So again, I'm going to start with 100%, and that's everything. That's 200. If I want to add on 15%, I'm going to find 10% first. That's easy. That's a tenth of that. It's going to be 20. 5% is pretty easy to find. It's half of 10%. It's going to be 10. So if I add those together, the 100%, the 10, and the 5 make 115%. That's a 15% increase. 20 and 10 and 200 makes 230. So that's my answer, 230. That's an easy 3 marks. Question 9. The scale drawing shows the positions of 2 towns A and B. Scale 1 centimetre represents 10 kilometres. Find the actual distance between town A and town B. Okay. So what you're going to need to do is get your ruler out and measure the distance between these 2 towns. Okay, so that distance there, basically from there to there. I'm just going to draw the line in. Now, if you measure this carefully with your ruler, you should find it is 7 centimetres. Okay, and then 7 centimetres, using 1 centimetre represents 10 kilometres. That's equivalent to 70 kilometres then, isn't it? Okay, so that is going to be the distance then between those two towns. So that's going to be 70 kilometers. And it says, on the scale drawing, mark and label the position of town C with a cross, which is 55 kilometers. Town C is, part B says, town C is 55 kilometers from town B on a bearing of 330 degrees. On the scale drawing, mark and label the position of the town C with a cross. Okay, so we're going to have to, from town B, we're going to have to head off on that bearing of 330 degrees, and then we're going to have to go this far. Now, using the scale of 1 centimetre represents 10 kilometres, 55 kilometres is going to have to be a 5.5 centimetre line. So that's how long it needs to be, but I need to kind of work out in what direction I need to draw it. Okay. Now, bearings are always given clockwise from north. Okay, so the north line here is 0, 0, 0 as a bearing. Then going around clockwise, 0, 9, 0 is east, 1, 8, 0 is south, 2, 7, 0 is west. So 330, that's going to be kind of in that direction, isn't it? 330. Okay, so if you think about it, it's going to be 30 degrees back from the north line, isn't it? Because there's 360 degrees in a full turn. Okay, so what I'm going to do is I'm going to put my protractor on the north line, centered at B, but the opposite way round, and I'm going to measure a 30-degree angle from there. Okay, I think it's about there. So I don't know if you can see that little dot. Let me just make it a bit bigger. That's the dot I kind of measured at the end of my protractor. So then taking our ruler again and then measuring off in that direction, we want to go a distance of 5.5 centimeters in that direction, don't we? 1, 2, 3, 4, 5.5 is about there. So I make it about that long. So that line should be 30 degrees back from this north line, and a distance of 5.5 centimeters, which is equivalent to 55 kilometers then, isn't it? So then that point there at the end of the line, that is going to be our town C. So that's C up there. Oh, it says on the scale drawing, mark and label the position of town C with a cross. Okay, so let's make sure we do what we're told. Put a little cross on C there. Okay. Question 10. Hero and Ling work at a restaurant. Hero is paid £9 an hour and Ling is paid £10 per hour. 1 week, Hero works a total of 30 hours. Ling earns £50 more than Hero that week. Work out the number of hours that Ling works. Okay. So Hero works a total of 30 hours and Hero is paid £9 an hour then, isn't he? So how much does Hero earn in a week? So Hero, he earns, that's going to be the 30 hours he works multiplied by the £9 an hour that he earns. Okay, so 3 9s are 27. So yeah, so my 3 times the 9 is 27, plus I've got an extra 0 on the end. So I'm going to add that extra 0 on the end here then, isn't it? So that's 270, that makes it. So he earns £270. Now Ling earns £50 more than Hero that week. So Ling earns what Hero earned plus another 50 quid. So that takes him up to £320. Okay? Work out the number of hours that Ling works. We know that Ling earns £10 an hour, and we know how much he earned. He earned £320. So if we divide his weekly earnings by his hourly pay rate, so 320 divided by 10, that should tell me the number of hours that he worked. That's pretty easy to do. 10 just divides in like that, leaving me with 32. So we know that he worked 32 hours. Okay, so that's Ling, that's Hero. Nicely set out. 32 hours. Question 11. Work out the cube root of 64 times a half squared. Okay, so what's all this then? This looks quite complicated. But the cube root of 64, what times itself 3 times is 64? Well, it's 4, isn't it? So 4 times 4 is 16 times 4 is 64. So the cube root of 64 is just 4. And then if I square something, then I need to apply that square to both parts. So that's going to be 4 times 1 squared over 2 squared. Now 1 squared is just 1, 2 squared is 4. So I've got 4 times a quarter here, haven't I? Which I know what that is because those two just cancel each other out. And that just leaves me with 1. So what is cube root of 64 times a half squared? It's 1. Question 12. Sasha is trying to remember a 4-digit PIN number. Sasha knows it has the following digits and that the first digit is a 9. So it's made up of a 9327 and it's definitely 9 in the first slot. Write down all the possible orders for Sasha's 4-digit PIN number. It starts with a 9, so it's going to definitely start with a 9. So you could have 327 the way it is there, or it could be 9 and we can switch the 2 and the 7 around. It could be 372, or it could be 9 at the beginning and then it has a 2 there, and then it would have to have a 3 and a 7 on the end, or it could be 9273 the other way around. Or if I put the 9 at the beginning and then have the 7, then I've got the 3 and the 2 left over, or it could be the other way around, 9723. Okay, so I've got 6 different combinations that I could try. Probably get through that without the device locking up. Part B says Sasha tries one of these orders at random. Write down the probability that the last digit of the PIN number that Sasha tries is 2. Well, the probability that the last digit is 2 is successful outcomes, of which there are 1, 2, isn't there? There are 2 numbers that end in 2. So there are 2 outcomes that would be the last digit of the PIN number that Sasha tries is 2, out of a total number of things that she's trying from. So there are 6 different outcomes. So it's just 2 over 6. Okay, now you could cancel that down to 1 over 3, but you don't have to with probability. It's probably best that you don't bother. Question 13. Ryan is making a sequence of patterns using counters. Here are the first 4 patterns in the sequence. He's got 3, then 6, then 10, then 15. These are actually the triangle numbers, aren't they? If you know your number patterns, these are the triangle numbers. Ryan starts with 80 counters. Ryan says, I still have enough counters to make patterns 5 and pattern 6. Is Ryan correct? Show how you decide. Well, how many has he used so far? Counters used. Counters already used. What's that? That's going to be equal to the 3 that are in the first one, plus the 6 that are in the second one, plus the 10 that are in the third one, plus the 15 that are in the fourth one. So how many has he used up? That's 25 and 9. That's 34 counters. So he's used 34 counters. So then the counters remaining, that's going to be the 80 counters that he started with here, look. Okay, minus the 34 counters that he's already used. So 80 minus 34, that's going to give me 46. So that's equal to 46. So he's got 46 counters to make these next 2 patterns. Now, has he got enough counters? So U5, the 5th pattern, I'm going to take the number of counters in pattern 4, which is 15. I'm going to add on another row. So I don't know if you've noticed, each time we're adding a row. So from the 2nd pattern to the 3rd pattern, we added those 3. Then we added those 4. Then we added those 5. So the next one, and we're going to add 6 onto, isn't it? So it's going to be 15 plus 6. That's going to be 21 in the 5th pattern. And the 6th pattern is going to be 21 plus 1 more. It's going to be 21 plus 7. That's going to be 28. So between them then, so the 21 plus the 28 is 49. So that's the counters needed. It's 49, and he's only got 46. So he hasn't got enough, has he? So no, because he requires 49 counters to build 5th and 6th pattern, and he only has 46 counters remaining. Okay, so B part 1, complete the table below for the addition of counters in consecutive patterns. So pattern 1 was 3, and 3 plus 6 is 9. Pattern 2 plus pattern 3 is 6 plus 10, which is 16. So pattern 3 plus pattern 4, that's going to be 10 plus 15. That's equal to 25. Okay? And then part 2 says the number of counters in pattern K plus 1 is 144. Find the value of K. Well, I don't know if you noticed, these are the square numbers, aren't they? So this first pattern is 3 squared, this is 4 squared, this is 5 squared, and we want to go down to this next pattern, which has got 144 in it, and that's 12 squared. Okay, so at the moment we've got pattern 3 and 4, which is 5 squared. To get up to 12 squared, we're going to go down another how many rows? So 12 take away 5, that means we've got another 7 rows to get down to 12, isn't it? Now every row we're increasing the pattern by 1, so by the time I get down to the 7th row, my pattern is going to be 7 times higher than these two, isn't it? So it's going to be pattern 10 and pattern 11 then, isn't it? That's going to give me 144. So that means I've got pattern K and pattern K plus 1. K must be 10 then, mustn't it? Because this pattern K is that one there, it's the 10, and this pattern 11 is one more than K, one more than 10 is 11. Okay, so K is going to be equal to 10. Question 14, a student is buying some gifts for their friends. The gifts are shown below with the prices. So a keyring is £3.50, a badge is £2.99, a wallet is £7.50. The student has £50 to spend. They first buy 6 keyrings and 2 wallets. They then buy badges with the remainder of the money. Work out the maximum number of badges that the student can buy. You must show your working. Okay, so I think what we need to do is to work out how much you spent so far, and then deduct that from the £50. See what we've got left over for the badges, and then see how many badges we can buy after that. Okay, so that's my plan. So first off, let's work out what she spent. So she bought some key rings. How many key rings? 6 key rings. So we need to do 6 lots of £3.50. So on key rings, so that's 6 times £3.50. Well, two £3.50s would be £7. So times that by 3, that's going to be £21, isn't it? So she's going to spend £21 on key rings. Then she buys wallets. How much did she spend on wallets? So she's got 2 of those at £7.50 each. So double £7.50, that's £15, isn't it? So adding those together, how much is that altogether? So she spent 21 and 15, that adds up to £36. So she spent £36. So what's she got remaining? So she's remaining with the £50 she had to start with minus the £36 that she's just spent. So 50 minus 36, that is 14. So she's got £14 remaining, and that's the money that she's got to buy badges with. So we need to work out how many times £2.99 fits into £14. Okay, and now divided by 2.99 is pretty hard, but I'm going to say that £2.99 is pretty much the same thing as £3. And so if I divide 14 divided by 3, I can see that that goes in 4 times remainder 2, doesn't it? Goes in 4 times remainder 2. Okay, so that means we can afford 4 of them. We can afford 4 badges. So how many badges can we afford? We can afford 4 badges. So what is 4 lots of £3.9? So what is 4 lots of £2.99 then? Well, 4 lots of £3 would be £12. So 4 lots of £2.99, that's a penny less, isn't it? So that'd be 4 lots of a penny less. So it's going to be £11 and then 96 pence, isn't it? That's how much they cost. Okay, so then the remaining is going to be what the £14 that was originally left over minus the £11.96. So 14 minus 12 would be £2, and then we're going to have four extra pence left over then, aren't we? So that's going to be £2.04. Okay, so that's the remaining money, £2.04. Right, question 15. Taylor performs in a show. Taylor spends 1/8 of the show singing, 1/4 of the show dancing, and the remaining 55 minutes backstage. Work out how long the show lasted. Give your answer in hours and minutes. You must show your working. So I think my plan is to add those fractions together. So work out how much of the show she is performing in. Take that away from 1 to find out how much of the show she isn't performing in, and then equate that with 55 minutes. And then see if we can scale that up to the length of the full show. Okay. So time performing is going to be 1/8 for the show where she was singing, plus 1/4 of the show where she was dancing. So adding that together, what's 1/8 plus 1/4? Well, 1/4 is 2/8, isn't it? Just times in top and bottom by 2. So that's going to give me 1/8 plus 2/8, which is 3/8. So time not performing, that's going to be 1 minus 3/8 then, isn't it? So that's 5/8. So if she's performing for 3/8 of the show, then she's not performing for 5/8 of the show. So that means that 55 minutes is 5/8 of the show. So if I want to get the length of the show back again, so the length of the show, it's going to be those 55 minutes divided by 5/8, which in other words of doing that is 55 times in by, and then flipping that fraction over and getting 8/5. So 55 times 8/5, so 5s into 55 go 11 times, and 11 times 8, that is 88. So that's 88 minutes. Now, but we want hours and minutes here. So there are 60 minutes in an hour. So that's 1 hour then, because it goes 60 goes into 88 once, and the remainder is going to be 28 then, isn't it? So it's 1 hour and 28 minutes. Question 16. Complete this identity by writing in the missing numbers. Okay, so we've got a missing number that goes here, it's something x, so it's the coefficient of x on that first bracket. And we've got something that's being subtracted right at the end here. Now these two things are equal to each other. Now with identities, you don't want to be moving things over the equal sign. You want to be working on each side separately, making it more look like each other. That's generally the rule to get these done. So I'm going to start off by looking at the right hand side. I've got 14x minus 6 lots of x minus 2 minus something. So if I just multiply out that bracket, let's see what I get first. So I get 14x, now minus 6 times x, and minus 6 times minus 2 there. Minus 6 times x is minus 6x, and minus 6 times minus 2 is actually plus 12. And then we've got minus our mystery number still that we don't know what it is. Okay, so let's just tidy up that because we've got some like terms there. So I've got 14x minus 6x. Now that is, well, that's 8x, isn't it? So I've got 8x plus 12 minus mystery number, and that must be equal to the same thing on the other side. Now the thing on the other side, I've got another bracket that I can multiply out. I've got 4 times something x, and I've got 4 times 1. Okay, now the 4 times something x, I'm not quite sure, so I'm going to have like some sort of value of x. I'm not quite sure what it is yet, but I do know what 4 times 1 is. That's 4, so that's plus 4. So if I equate it then with the other side, look, then it must be that the something in front of x must be equal to 8 then, mustn't it? Because it matches with the 8 on the other side. And it's going to be plus 4. So on the other side, and the thing I take away from 12 needs to get me down to 4 then, so it matches with the 4 on the other side then, mustn't it? So 12 take away what is 4? Well, it's 12 take away 8, isn't it? So that mystery number there is 8. So that means that's 8, which means that's 8. So it must have had a mystery number of 8 on the end. And on the other side, I can now see that because this is ax, then this is ax. So that's got to be ax there then, isn't it? It's still ax there. So then what times 4 times what x gives me ax? Then that's going to have to be a 2 there, isn't it? So when I times it by the 4, I'm going to get the ax. Okay? So by kind of working our way down one and then back up the other, we can see that the first blank should be 2 and the second blank should be 8. Question 17. Vector A is 3, 2. Vector B is 1, minus 4. And part A says, on the grid, draw vector A. Now we know that vector A is this column vector 3, 2. Now the top number in a column vector is the distance in the direction of x, and the bottom number is distance in the direction of y. So if I want to draw a vector, you just need to pick a starting point on your grid paper like that, and then 3 followed by 2 means I'm going to go 3 units in the direction of x, 1, 2, 3, and I'm going to go 2 units up, 1, 2. So that's going to take me to this point here. Okay, so the vector A is the straight line then that joins those 2 points together. Okay, so I'll just get my ruler out and draw that line on. Then that is the vector A. Okay, I'm just going to get rid of my yellow and green bits because they're not really part of my drawing. So yeah, so that's the vector A there then. Now for the second one, we need to draw the resultant vector A plus B. A plus B. Now there are 2 ways of doing this. Okay, now the first way is just to draw vector A and then draw vector B on the end of it, and then the resultant vector will be one followed by the other. So again, if I pick a point on my graph and I draw vector A, I already know that that's 3 along and 2 up from earlier. So that's my vector A from there to there. Now the vector B is 1, minus 4, which means 1 in the direction of x and minus 4 in the direction of y. So from the end of A, if I go 1 more in the direction of x and minus 4 up, which is the same thing as 1, 2, 3, 4 down, it's going to take me to this point down here. Okay, so the vector B was the line that was going straight down like that. So that's my vector B going down that way. Again, I'm just going to get rid of the yellow and greeny bit. Okay, so then the vector A plus B is that where you get to, we're starting at this point on the left. I went along vector A and I went along vector B. So the straight line joining your starting point and your final end point must be the vector A plus B. So this line going straight between them like that, that is the vector A plus B. Okay, so that's one way to answer this question. You draw a vector A, then you draw a vector B on the end of it, and then the resultant vector is that line there from the start of A to the end of B. The alternative way of doing it is using the column vectors themselves and doing a bit of maths with that. So I could have instead of just added these column vectors together. So 3 plus 1, because when you add column vectors you add like with like. So the 3 plus 1 gives me 4, and the 2 minus 4, that gives me minus 2, doesn't it? Because 2 plus negative 4 is minus 2. So now I've got the vector 4 minus 2, and you'll see if I started at my starting point and I went 4 in the direction of x and then minus 2 up, it takes me to the end point as well. So that's an alternative way of doing it. So instead of drawing one vector and then the other vector and then joining them up, you could have just worked it out with the column vectors instead and then drawn your resultant. Now, which is better? I don't know. Pretty muchness really. Whichever one you fancy. The diagram shows 2 straight lines crossing a pair of parallel lines. Write down the value of A given a reason for your answer. Okay, so where's A? A's down here, look. And A is an angle between a line and a transversal like this, and that line that it's on is parallel to another line. It's this one here. So I've got an angle which is on the same side of the transversal as this one up here. So we call these corresponding angles then. So A is equal to 125. So A is equal to 125 degrees, and the reason is corresponding angles. So So you do need to know these words associated with parallel lines, so corresponding, alternate, co-interior, so that you can pick up the second mark when you're finding these angles in the diagram like that. Okay, so we got A done. What about B? B's up there at the top of that triangle. Now, how can I find that? Well, I know because this angle here is 75 degrees here, and this one here is what we call vertically opposite. That one there must also be 75 degrees, mustn't it? Okay, and this one over here is on a straight line with A, and we know that A is 125, so angles on a straight line add up to 180, means that that angle there must be 180 minus 125, which gives me an angle of, what's that, 55 degrees. Okay, so we've got a triangle where we know two of the angles, 55 and 75, and we want the third angle. So we can use the fact that our angle B plus the 55 angle I just found plus the 75 degree angle added together is going to be 180, isn't it? Because there are angles in a triangle add up to 180 degrees. And so adding those two angles together, that's B plus 55 and 75 make 130. Okay, so then B is going to be 50 degrees, isn't it? So B is 50 degrees. Question 19. A sphere has radius 3 centimeters. Calculate the volume of the sphere. Give your answer in terms of pi in its simplest form. The volume V of a sphere with radius r is V equals 4/3 pi r cubed. Okay, so this is actually quite a straightforward question. We've been given the formula. We've been given the value that goes in the formula. We just got to take the formula and stick in the value we've been given, haven't we? So the formula for the volume of a sphere, V equals 4/3 pi r cubed. So our value of r we were given up here is the radius is 3. So we're just going to have to plug 3 straight into this formula and work it out. So it's not that hard really. So 3 cubed in there then. So replacing r with 3, I've got that, haven't I? Okay. Now, rather than working out 3 cubed, much easier just to divide that 3 into this series of 3's up here. If you've got 3 cubed, that's 3 times 3 times 3. So if you divide it by 3, you're getting rid of one of those 3's that you're multiplying it by, aren't you? So that's the same thing as 3 squared. So 3 cubed divided by 3 is 3 squared. 3 squared is 9. 9 times 4 is 9, 18, 27, 36. So that makes 36 pi as my answer, 36 pi. Okay, and that is my answer in terms of pi in its simplest form then, isn't it? So 36 pi is my answer. The diagram shows a prism of length 10 centimeters. The cross-section of the prism is a right-angled triangle. The base, B centimeters, is 2 centimeters longer than the height, H. The volume of the prism is 240 centimeters cubed. A student is explaining how they worked out the value of B. They say B is 6 because that means H is 4, and 6 times 4 is times 10 is 240. Describe the student's error and find the correct value of B. Well, what they've done here is a bit of a classic mistake. The front face of this prism is a triangle, and they have considered it to be a rectangle, haven't they? They've just multiplied what they think B and H together is, and then they're saying if you take that and multiply it by 10, you're going to get the volume of the prism. But this, like I say, this part here is actually the formula for finding the area of a rectangle, not the area of a triangle. So the error is the student used the formula for a rectangle and not a triangle. So if the area of the triangle is equal to half base height, and then that is equal to 240 divided by 10, because we know that the volume is 240, and so the area is going to be 240 divided by that length then, isn't it? So that gives me 24. So half base times height is 24. So that means my base times my height is equal to 48 and not 24. So we're looking for two numbers that have a difference of 2 and multiply it together to give you 48. So what could that be? It could be 6 and 8, I guess, couldn't it? So 6 times 8 is 48. That would work. So 6 times 8 is equal to 48. So I'm saying that the height is 6 and the base then is 8. Okay, so the base is going to be 8 here. The table shows the ages and heights of 12 children. The points of the first 8 children, the shaded part of the table above, are plotted on the scatter diagram. And part A says plot the points for the remaining 4 children. So we've got these ones to plot, haven't we? So 5 versus 1.14, 7 versus 1.124, 9 and 14, those two there. Okay, so I'm going to carefully plot those points on the graph. So 5 goes with 1.14. Now notice the scale has got 5 divisions between 0.1, so each one is going to be 0.02 then, isn't it? So I'm going to have to go 2 little squares above 1.1 if I want to draw 1.14 then. Okay, 7 goes with 1.24, so again I'm going to go 2 little notches above. The next one, 9 goes with 1.26. And 14 goes with 1.68. That one should be fairly easy to plot because it's right on the edge. 168. So that's going to be one little notch down from 1.7, isn't it? And right on the end, so it's there. Right, so I've plotted my points. Describe the type of correlation shown in the completed scatter diagram. Well, if you look from left to right here, the points are quite clearly running a band up here. Got one kind of sitting a bit proud, isn't it? It's a bit kind of further up than the others. But the rest I can easily fit under my ruler like this, and an upward band going through the middle. This is actually quite a good technique for finding the line of best fit. If you've got kind of a clear ruler, just kind of try and lay it out over all of your points. Try and capture all of them under the ruler, and then you can just pull your ruler down a little bit, about halfway, and then you can draw your line of best fit. Okay, so that's what I'm going to do here. So you can see from left to right, the line of best fit is going upwards. So that indicates positive correlation, and doesn't it? So what type of correlation is shown? It is positive. It's not normally necessary to comment on the strength. So it is quite strong positive, apart from that weird one point that's a bit further away. But yeah, you don't really need to give the strength to the correlation, just so if it's positive or negative. Part C says one of these children is taller than expected for their age. On the scatter diagram, circle the point representing this child. Well, I'd already noticed that outlier. It's here, look, this is the outlier. Supremely tall 6-year-old. Yes, they're the odd one out. And then D, Kai is 8 years old. By drawing a line of best fit, which I've already done, estimate Kai's age. Okay, so once I've got the line of best fit in place, I can use it to estimate other values. So I don't have any 8-year-olds on my graph already, but if I find 8 on the scale and read up to the line and then across, I can use that as an estimate for the height of what an 8-year-old would be. Okay, so along there. Okay, so it kind of ends up there, doesn't it? It's about 2 notches down from 1.3, so I make that 1.26. I'm going to say 1.26. Now, if you drew your line of best fit slightly differently from mine, you might get a different answer to me. Don't worry, you'll be marked against your own line of best fit. So wherever your line of best fit is, you read up and across from that, and that should be your answer. Okay? Describe an assumption you have made in giving your answer to part D. What's my assumption? So what we're assuming here is that the child fits the same pattern as all the other ones, doesn't it? So it isn't like a freakishly tall person. It's just kind of generally follows the same pattern as everybody else. So given assumption, the child fits the general pattern of other children. Part E says, explain why using the data to estimate the height of a child that is 17 years old may be unreliable. Okay, well, 17 is well outside of the range of the data we've got, isn't it? We've got values between 2 and 14. So 17 is going to be outside of that data range. We call it extrapolation. So we would be extrapolating. That's the proper name for it, extrapolating, as data as 17 is beyond the range of data points. In brackets, that runs from 2 to 14. Okay. Question 22. The diagram shows a right angle triangle. We've got an angle of 30 given. The hypotenuse is 14. And we've got another side marked A. We need to work out the value of A. So you haven't guessed already, this is a trigonometry question in a right angle triangle. So we're going to be using our mnemonic SOHCAHTOA to work out which ratio we need to use here. Okay. Now, before we can decide the ratio, let's just label up the sides and see which sides we've been given, which ones we want, and which ones we don't care about. Okay. So I normally start with the hypotenuse because it's the easiest to spot. The longest side is the 14, isn't it, by a country mile, much longer than the other two lines. So that must be the hypotenuse. Then the other two you label up relative to the angle you've been given. So I've been given this angle down here of 30. So A is opposite that angle, isn't it? It's on the opposite side of the triangle to the angle. So this is the opposite. And then the other side then, which joins onto the angle, that's the adjacent, because adjacent in the English language means next to. Okay, so that means we want the opposite. We've got the hypotenuse. We don't have the adjacent, don't really care about the adjacent. So any of the ratios with the adjacent in, A, we don't want. So we can get rid of cat and we can get rid of toa. So it must be SO. Okay, so sine has the opposite and the hypotenuse in it, which is the ones we're interested in. Cos and tan have A in it that we're not interested in, so it's not that one. Okay, so now we know it's sine. Let's write out the full formula for sine. Sine theta is equal to the opposite over the hypotenuse. Okay, and then subbing in what we know. So we know that sine is of the angle is 30, and that's equal to the opposite, which is A, divided by the hypotenuse, which is 14. Okay. Just rearranging, multiplying both sides by 14. I'm going to get A is equal to 14 sine 30. And then we just need to reach for the calculator and type it in. Oh, no, we can't because it's the non-calculator paper. Okay. Now, you have to remember a certain number of these angles and their trigonometric ratios for your paper. And this is one of them that you need to know. You need to know the sine of 30. Okay. Now, there is a handy way of remembering them all. So what I do is I draw a big square root symbol like this, and then I'm going to write sine and cos next to it there, and then under the square root I'm going to write 0, 1, 2, 3 and 4, and then going back the other way I'm going to get 4, 3, 2, 1, 0. Now these correspond to the angles that I need to find, so I need to remember I need to know the angle for the sine, cosine, tangent for 0, I need to know it for 30, I need to know it for 45, I need to know it for 60, and I need to know it for 90. Okay, it's not quite finished. I need to put a big line down here and write a 2 on the bottom like that. Okay, now the way this little handy table thingy works is that if I want to have the sine of 30, I look up sine, I look up 30, and I see where they meet is there. Okay, so that tells me that the sine of 30 is equal to, don't forget I've got a square root there, I've got the root of 1, so root of 1, so the root goes over all of them, so all of them are rooted, and then I picked out the 1 because that was the 30, and then that needs to be divided by the number on the bottom here, this 2, so that needs to be part of my answer as well, so 2. Okay, so all you need to do is you need to pick out the number under the big square root symbol that you need, and then put it in under here like a root of that number over 2, and then that's going to be your trigonometric ratio that you need. Now this one actually tidies up a little bit because the square root of 1 is just 1, so this is just the same thing as a half. Okay, so the sine of 30 is a half, so that means if I put it back in here, A is 14 times the sine of 30, and the sine of 30 is a half, then a must be 14 times a half, and 14 times a half is just 7, and isn't it? So my answer is 7 watt centimeters. Oh, well, the value of a is 7. And it's a centimeters, isn't it? So a is 7. Question 23a. Factorize x squared plus 10x plus 24. Okay, now this is a quadratic expression, and when you factorize a quadratic, mostly they go into double brackets like this. Now I've got an x squared term at the beginning, so I'm going to have an x and an x here and here, so that when they multiply together it gives me x squared. Now I've got a 24 at the back here. What are the factor pairs of 24? 24 has factor pairs 1 and 24, 2 and 12, 3 and 8. There's lots, isn't there? 4 and 6. And that's it. No more. That's all of them. Okay, so the pair I want is going to be one of these pairs, because these are the two numbers that multiply together to give me 24. And I have to pick one of the pairs to put in the bracket then. Now I have to pick them in a way that they add up to 10. Okay, so they need to add up to 10. So which one of these pairs add up to 10 and is also a factor pair of 24? It's this one, isn't it? 4 and 6. So I'm going to put plus 4 here, plus 6 here. Okay, so x plus 4, x plus 6 is how it factorizes. All right, now part B says write down the solutions for x squared plus 10x plus 24 equals 0. So that's the same expression that we had before, so I can replace that quadratic with the two pairs of brackets that I just worked out and equate that with 0. Okay. Now if I've got two things multiplied together and it gives me 0, that means one of the things or the other or both must have been 0 to start with. So if x plus 4 was equal to 0, then that means that x must have been minus 4, because minus 4 plus 4 is 0. Or if x plus 6 was equal to 0, then x is going to be equal to minus 6, then because minus 6 plus 6 is equal to 0. So they're my two solutions then. X equals minus 4, x equals minus 6. Oh, I just didn't write the answer down there. Might as well fill it out while I remember. The volunteer packs boxes for a charity. They can pack 5 boxes in 45 seconds. Use this information to show that they can pack 55 boxes in less than 9 minutes. Okay. So again, I can also do this as a bit of a ratio. So the ratio of boxes to seconds, boxes to time, I guess. We're talking 5 boxes in 45 seconds. Okay, so what do we want? We want 55 boxes. Okay, so 55 boxes is times in through by 11. Okay, so if I'm going to times through by 11 that side, I need to times through by 11 over here as well. So what's 45 times 11? Well, 10 45s would be 450, plus another 45 would be 495, then, isn't it? Okay, so it's going to be 495 seconds. So what's 495 seconds in minutes? So 495 seconds equals how many minutes then? So in minutes, 60 minutes, 60 seconds in a minute. How many 60s go into 495? So 60, 120, 180, 240, 300, 360, 420, 480. I count 8. Goes in 8 minutes. 480 taken away from 495 would leave 8 minutes and 15 seconds. Okay? So 495 seconds is 8 minutes and 15 seconds, which is less than 9 minutes. Less than 9 minutes. Okay. What assumption did you make in part A? Well, I assumed that he could just keep on going, couldn't I, at the same pace without tiring. Okay. Obviously, if you do something over and over and over again, after a while you get like a little bit tired of doing it, don't you? And you kind of slow down a bit. But we're assuming here he kind of carried on packing boxes like a robot at the same speed for the full amount of time. So that's my assumption. The volunteer continued to pack boxes at the same speed without tiring or taking a break. Okay, a student draws two different regular polygons. The exterior angle of one polygon is P, the exterior angle of the other polygon is Q. The sum of P and Q is 112, the difference between P and Q is 32. Find the number of sides of each polygon you must show your work in. Okay, so we've got a pair of simultaneous linear equations here, don't we? So we know that the sum of P and Q is 112. So sum means added together, doesn't it? So that means that P plus Q is 112. And the difference between P and Q is 32. Now, we don't really know which one is bigger, P or Q, but I'm just going to assume P is the bigger one of the two. It doesn't really matter because we're just finding two values, aren't we? So I'm just going to assume that P is the bigger one, so that P minus Q is equal to the difference of 32. Okay, so that's my equation 1, that's my equation 2. Now, to eliminate one of my variables to solve this pair of simultaneous equations, what I'm going to do is just going to add these two equations together. So equation 1 plus equation 2, what's that going to give me? Adding those together, P plus P is 2P, Q plus negative Q, they cancel each other out, and 112 plus 32, that is 144 then, isn't it? Okay, so if 2P is 144, then P is going to be half of that, then it's going to be, what, 72 degrees? Okay, so once I know P, I can just sub it into one of my original equations. So substitute P is equal to 72 into equation 1. What am I going to get? I'm going to get 72 plus Q is equal to 112 then. So then taking 72 away from both sides, Q must then be equal to 112 take away 72. What's that? Is that 40? Okay. So P has an angle of 72 degrees, Q has an angle of 40 degrees. So what does that mean in terms of the number of sides? Now, an exterior angle of a regular polygon is equal to 360 divided by the number of sides n. So then the number of sides n must be 360 degrees divided by the exterior angle as well then, mustn't it? Okay, so for polygon 1, n1, we're going to get 360 then divided by our first value, p, I guess 360 divided by 72. How many times does 72 go into 360? I hope it goes in nicely, because otherwise I'm going to be a bit stuck. Doesn't it go in exactly 5 times? I think so. 5 lots of 72 is 360, isn't it? So one of my polygons has got 5 sides, and the other one, N2, I'm going to get by taking 360 and dividing it by Q, which we said was 40 degrees. So what's that? 4 is into 36. That goes 9 times, and doesn't it? Okay, so then I've got a 9-sided polygon as well. So I've got a pentagon and a nonagon then, haven't I? Okay, we're done. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.